Sam throws a stone on the sand. He throws another stone into the pond. It sinks. Are there gaps in water so that the stone can pass through it? What are sand and water made of? What holds sand particles together? Even our ancestors organized the world into earth, water, air, fire, and space. Matter occupies space and has a definite mass. Does all matter behave in the same way? What distinguishes different types of matter? It is the space between the particles of matter. Matter is particulate. It is not continuous. There is space between the particles. Take a glass jar and fill it with gravel. Is the jar full? No, it appears to be full, but the jar still contains some empty space. To prove this, let us add some sand to the jar. When we shake the jar, the sand settles into the spaces between the gravel particles. There is no space that can be seen. If we then add some water, it occupies the minute spaces in between the sand particles. What do you understand from this activity? Matter is not continuous. It is particulate. It has space between particles. Which has more space? Solid, liquid, or gas? Gas has the most space. Liquid has less than gas, and the solid has the least space. Particles of matter are moving continuously. They have energy by virtue of their movement. This is called kinetic energy. When we increase the temperature, the kinetic energy increases, and hence the speed of the particle increases. Higher temperature increases the kinetic energy of the particles, so that they diffuse quickly in hot water. No, when we light an incense stick, it burns and fills the area with a pleasant odor. You are able to smell it from anywhere in the room. The strength of the force attracting the particles in incense vapors is smaller, and hence they diffuse easily in air. Whereas the strength of force attracting the particles in water is greater than that of the force attracting the particles in the smoke of incense sticks, and hence the rate of diffusion is slow in water. The attractive force between the particles in a solid chalk piece is high, and they are tightly held together. Why do naphthalene balls have a strong smell? Well, the molecules of naphthalene must be breaking away from the surface as a vapor, because otherwise we wouldn't be able to smell it. This change of state of a solid directly into a vapor is called sublimation. Observe what happens when iodine crystals are gently heated in an evaporating dish. Thus, solid iodine sublime. Purple vapors of iodine are formed. These vapors convert back into iodine on the cool sides of the upturned funnel. The change of state from vapor to solid is reverse sublimation or deposition. In most solids, the forces of attraction between particles are too high to allow much loss of particles from the surface. However, if energy is supplied by heating a solid, the particles gain enough energy to break away from the solid arrangement to form a liquid. The temperature at which this takes place is called the melting point of the solid. This change of state from solid to liquid is called fusion or melting. The heat energy required to convert 1 mole of solid into a liquid at its melting point is called the enthalpy of fusion. Now, if this liquid is cooled, the reverse happens. At some temperature, the motion of the particles is slow enough for the forces of attraction to be able to hold the particles as a solid. As the new bonds are formed, heat energy is evolved. This change of state from liquid to solid is called solidification. In the case of water, this change of state is called freezing. If more heat energy is supplied, the particles of a liquid eventually move fast enough to break all the attractions between them, and the liquid boils. The change of state from liquid to gas is called vaporization. The heat energy required to convert 1 mole of liquid into a gas at its boiling point is called the enthalpy of vaporization. Above its boiling point, a liquid exists only in its vapor state. If the gas is cooled, effect on them, and to condense the gas back into a liquid. Again, as those forces are re-established, heat energy is released. The change of state from gas to liquid is called condensation or liquefaction. Many elements such as hydrogen, oxygen, and nitrogen exist in the gaseous state at atmospheric pressure and normal temperatures. These can be liquefied by the application of sufficient pressure. Natural gas cylinders contain gases which are converted to the liquid state under high pressure. As water changes its physical state, it still consists of the same. Solids, liquids, and gases can be distinguished on 2 levels: the macroscopic and the submicroscopic. On the macroscopic level, solids, liquids, and gases can be distinguished from one another on the basis of shape, volume, compressibility, and density. The term submicroscopic refers to properties that are too small to be seen, even with the very best of microscopes. For example, the motion of molecules. The kinetic theory is a good way to relate the micro world with the macro world. This theory assumes that all matter is composed of very small particles which are in constant motion. The particles attract each other with a force that grows weaker as the distance between the particles increases. Heating a substance increases the rate of motion of its particles. In a solid, the particles are so close that the force of attraction holds each molecule in a fixed position, and the entire substance maintains a definite shape and volume. When a solid is heated, the kinetic energy of the particles is increased, and they are able to overcome the forces of attraction holding them in place. In the liquid state, the molecules have more energy and move faster. They can break out of their rigid structure and move past each other. This greater freedom of movement is characteristic of a liquid. The particles, however, stay close together because they are not moving fast enough to break completely free from the force of attraction that holds them together. They can change shape to adapt to their container, but they can't be compressed into a smaller volume. Why does the quantity of water kept in an open container decrease after a few days? Evaporation takes place at all temperatures below the boiling point of the liquid. It is due to evaporation that wet clothes dry out, and bread left out in the open dries and becomes hard. Without evaporation, the puddles of water formed after rain would not dry. The particles have an average kinetic energy which depends upon the temperature. However, owing to the collisions, some particles have a higher than average kinetic energy and some have lower. When a particle at the surface of the liquid gets enough energy to overcome the forces of attraction of the liquid, it escapes. This is evaporation. When heat energy is supplied to a liquid, the kinetic energy of all the particles increases. The molecules move so fast that the force of attraction among them cannot hold them together at all. This is characteristic of the gas state. In the gas state, the separation between particles is very large compared to their size. The particles move randomly and change direction only when they bump into other particles or the sides of the container. Therefore, gases have no fixed shape or volume. The motion of molecules is temperature dependent. A decrease in temperature means a decrease in the average energy of the molecules. Hence, the lower the temperature, the more slowly the molecules move. On cooling, the gas changes back into its liquid state. On further cooling, a liquid changes into its solid state. That is why the temperature of a substance determines its state. Is there a temperature at which the motion of the molecules stops completely? At absolute zero, all classical molecular motion stops. Absolute zero is equal to 0 Kelvin, or minus 273.15 degrees Celsius. However, molecules cannot cease all motion. So at 0 Kelvin, they still vibrate with a certain energy, known as the 0 point energy. Over 99% of the matter in the universe consists of a fourth state of matter, called plasma. Plasma, or ionized gas, exists at extremely high temperatures in the sun, stars, and interstellar space. Plasma can be seen in neon signs, plasma TV screens, and we come across evaporation in our everyday life. Drying clothes in the sun is a good example of evaporation at work. Similarly, as soon as you apply body spray, it disappears. Even perspiration evaporates after some time. Streets that are wet after rain eventually dry out as the sun shines. Spilled gasoline or petrol evaporates rapidly into the air. Even water from the surface of the sea evaporates, thus helping the formation of rain. Evaporation is a surface phenomenon. The wider the surface area, the greater the rate of evaporation will be. That is why a cloth spread on a rope dries faster than the one not spread out. Water in a glass doesn't dry quickly because the exposed surface area is relatively small. When the temperature increases, the kinetic energy of the particles also increases. So, after an increase in temperature, the loosely held surface particles escape very quickly into the air. Hence, clothes dry faster in summer than in winter. That is why we struggle to dry clothes on humid days and in coastal regions. When the wind speed is higher, the surface particles move away with the wind, meaning quick evaporation. When we mop the floor, we switch on the ceiling fan to dry the floor quickly, or any other nail polish remover. Nail polish remover leaves a cooling effect as it evaporates. Because when you apply any evaporating liquid, it takes away heat energy from your body. Let us do an activity to help us understand this. Take a 250 ml beaker and fill it with acetone. After a little time, touch the beaker. During evaporation, the particles of the liquid absorb energy from its surroundings to regain the energy lost during evaporation. This absorption of energy makes the surroundings cool. The heat absorbed to convert liquid into vapor is called latent heat of vaporization. The value of latent heat of vaporization for water is 540 calories per gram. You can easily catch cold if you are wet. Perspiration is the cooling mechanism of our body. The heat is absorbed from the body, leaving it cool. Cotton, a good water absorber, absorbs sweat and exposes it to the atmosphere for easy evaporation. On a hot, sunny day, people sprinkle water outside their houses or on their roofs to keep their houses cool. A glass containing ice-cold water has water droplets on its outer surface. When water vapor present in the air comes into contact with the ice-cold glass, it condenses as droplets. Water is the most precious resource. Tropospheric water vapor comes from evaporation over the oceans and plant transpiration. We also lose enormous amounts of water stored in lakes and dams through evaporation and runoff. If only this could be prevented. But evaporation is an essential part of the water cycle. Let us see how evaporation takes place. Zach noticed that the water on a wet floor dries fast than the water in a drinking glass. He already knows the boiling point of water is 100 degrees Celsius. Water vapor comes out when it reaches the boiling point. However, the remaining water on mopping the floor evaporates even at room temperature. We know liquid becomes vapor on boiling. Has the water on the wet floor reached the boiling point? To answer these questions, we must understand the difference between boiling and evaporation. The process of liquid changing into vapor below its boiling point is called evaporation. Evaporation can occur at any temperature, but boiling takes place only at certain temperature called boiling point. Boiling occurs throughout the liquid. Evaporation occurs only at the surface of the liquid. Bubbling is noticed during boiling, whereas there is no bubbling during evaporation.